All right, welcome to today's explainer. We're diving straight into a really fascinating math masterclass designed specifically for 8th graders. And the big idea here? Well, getting the right answer simply isn't enough anymore. You've actually got to learn how to effectively defend and justify your mathematical thinking. Today, we're going to explore how explaining your thought process is literally the secret key to genuinely deepening your learning. We'll see exactly how this curriculum teaches students to stand their ground and, mathematically defend their work. So here's our agenda for today. First, we've got the power of why. Then, converting and defending, multiplying scientific notation, and comparing large numbers. After that, we'll look at the student practice mission, and finally, wrap things up with the curriculum's lesson on morality and true education. Let's get into it. Section 1. The power of why. Deepening your learning through justification. The source material makes a really interesting connection right off the bat to 1 Peter 3:15, which says, "Always be prepared to give an answer to everyone who asks you to give the reason for the hope that you have." The curriculum draws this cool parallel, suggesting that just as you might defend your faith, students in math class should be able to clearly explain and defend their work too. It's all about building that confidence to say, hey, here's my answer, and here is exactly why it is true. So, why does this actually matter for students right now? Well, for one, the material notes they'll be expected to justify their reasoning on STAR tests and other major assessments. But honestly, it goes way beyond just passing tests. The lesson argues that being able to explain a method shows true understanding. It builds absolutely vital mathematical communication skills, and it strengthens a student's ability to look at a problem, do some error analysis, and see exactly where things went wrong. Plus, it perfectly prepares them for teamwork and even tutoring others down the line. All right, moving on to Section 2. Converting and defending, making massive numbers manageable. Just consider this massive number, 4,200,000. When you're dealing with huge distances in space or, say, tiny microscopic cells in science, writing out all these zeros every single time is just a recipe for making a mistake. So the challenge presented here is converting this giant standard number into scientific notation. The curriculum breaks this down into a super clear step-by-step process. Step 1 starts by placing the decimal right after the very first non-zero digit. So for our number, that turns 42 into 4.2. Now step 2 involves counting exactly how many places that invisible decimal moved from the very end of the original number to get tucked right between the 4 and the 2. Counting those jumps, we get 6 places. And then step 3 notes that because we started with a really large number, our exponent's gonna be positive. Put it all together, and the mathematical answer is 4.2 times 10 to the 6th power. But remember our big idea. The lesson stresses that simply having the answer isn't enough. It has to be defended. Here is the official justification statement they're looking for when a teacher or a test asks a student to explain their steps. You'd say, I moved the decimal 6 places to the left to make the number between 1 and 10. Because I moved it to the left, which makes the base number smaller, I used a positive exponent to keep the overall value exactly the same. Boom! You've just created a bulletproof mathematical defense. Next up, Section 3, multiplying scientific notation, combining massive values. So the next challenge the material throws at us is multiplying 2 times 10 to the 4th power by 3 times 10 to the 2nd power. Now, at first glance, looking at all those parentheses and exponents, it might seem a little intimidating, right? But don't worry, the curriculum breaks it down into simple, defendable steps. Here's how it works. Step 1 separates those front numbers, which by the way are called coefficients, and multiplies them. So 2 times 3 equals 6. Easy enough. Step 2 looks at the exponents. When you're multiplying with the same base of 10, the rule is you simply add the exponents. So 4 plus 2 equals 6. Then step 3 brings the whole shebang together. The final answer is 6 times 10 to the 6th power. And to defend this answer, the text provides this exact justification statement. When multiplying in scientific notation, I multiply the front coefficients and I add the exponents, since the base of 10 is the same. It also suggests adding that the result is still in correct scientific notation because 6 is between 1 and 10. The lesson really emphasizes that using solid vocabulary words like coefficients and base proves you're applying the rules of math with absolute precision. Which brings us to Section 4, comparing large numbers, finding the true giant. Okay, so when comparing 7.2 times 10 to the 5th power against 1.1 times 10 to the 6th power, human nature kind of makes our brains immediately jump to those front numbers. The gut instinct is to think, well, 7.2 is way bigger than 1.1. But falling for that visual trap will actually give you the wrong answer. The crucial point here is really understanding the rule of exponents as presented in the text. 1.1 times 10 to the sixth is actually the greater number, because the exponent of 10 always trumps the coefficient. The curriculum offers this justification. Even though 7.2 is greater than 1.1, the exponent of 10 is larger in the second number. That larger exponent means the number is an entire power of 10, meaning 10 times greater than the other. So comparing those tiny little exponents is actually the very first step in judging the size of scientific notation.
Moving right along to Section 5, your practice mission, applying your knowledge.
To lock all these concepts in, the curriculum provides a practice mission. It asks students to convert numbers, write out their explanations, and practice the multiplication rules while justifying the whole process. Interestingly, it also asks students to analyze a fictional student's error. That is a fantastic way to prove they truly understand the mechanics. Then, they compare those big numbers using their new reasoning skills. And finally, it challenges them to step into the role of the teacher and create their very own challenge question. Pretty cool, right? Finally, we arrive at Section 6, Morality and True Education, the HeroesmartAcademy philosophy. Now, the curriculum draws a really interesting parallel here at the end. It suggests that just as scientific notation helps us manage incredibly huge numbers, like 10 to the eighth, and incredibly tiny microscopic numbers, like 10 to the negative fourth, God provides perspective to manage the big and small moments in life. The text encourages students to recognize that regardless of whether their scale of influence feels huge or tiny, they can be used powerfully. Their role is simply to be faithful in both. This really illustrates the core philosophy of the HeroesmartAcademy Godly Learner series. They actively intertwine biblical morality with education, based on the premise that academic intelligence without a moral compass ultimately leads to pain. The curriculum straight up asks, what is the point of being highly intelligent if that brainpower is just used to make bad choices? Their stated goal is for students to be both highly intelligent and deeply good. The text concludes this whole thought by referencing Romans chapter 8, verses 6 through 7, which promises genuine peace of mind to those who keep their minds spiritual. The curriculum argues that engaging your mind in academic studies while keeping your heart firmly anchored in morality brings a profound peace that mere academic success on a math test just cannot give you. So, as we wrap up today's explainer, the source material leaves us with a final, powerful question to consider. How will you bravely justify your reasoning in math and your hope in life? Because whether you're defending a decimal point or defending a core belief, this curriculum aims to give students the exact tools, vocabulary, and understanding they need to confidently stand their ground. Thanks so much for joining me as we explore this fascinating approach to education.